Thank you so much. Let's keep it going for Kelly, and let's keep it going for Jayman. Really good presentation. I really liked it, and my presentation is going to be the same, but in English. So let's do it. I just came in from New York City. Nice weather here in Seoul. It's beautiful. Let's get started. Are you ready? Cool. So you guys all work in AI, right? Not really? So you're not, what are you doing here? Huh?
I'm working on a biology technology.
Got it. So who here is not working for AI? Can you raise your hands? 1, 2, 2. Got it. Great. Okay. So my presentation is going to be really simple, and a lot of that Jayman already covered. So I'm going to go through the slides really fast. And the first part is like a recap. It's really fun. The second part is a little bit more heavy, and then in the end, because I'm going to go through it really fast, I'm going to demo you the product, Pinecone, and then you can ask me some questions. Sounds good? All right, let's do it. So how do you make it full screen? Got it. Cool. I'm so sorry, technical issue. Technology is so hard. Cool, yeah, sounds great. Sounds good. So I'm going to talk about different versions of RAG. And let's do a little LLM recap, just because it's fun. And I'm sure everyone already knows. So in 2002, ChatGPT blew up the internet and got to 100 million users in only 2 months, beating all the other LLMs. Or, sorry, not LLMs, all the other apps that existed. And then I did some homework while I was on my flight, and I just wanted to imagine like how really ChatGPT is popular. So I went to Google Trends and I compared ChatGPT and Taylor Swift, and I found out that ChatGPT became almost as popular as Taylor Swift in the United States. And then in one day, which was yesterday, ChatGPT was more popular than Taylor Swift. And then I thought, maybe, you know, in Korea, Taylor Swift is more popular. So I changed United States to Korea, and what do you think? No? Yes, exactly. So apparently Taylor Swift is not popular in Korea at all, but ChatGPT is very popular. And I thought maybe because in Korea people really like K-pop, it's much better than Taylor Swift, right? So I added BTS, and then this is what I've learned. I've learned that ChatGPT is more popular than Taylor Swift and BTS combined. Yeah, and so ChatGPT came out, and right after ChatGPT, everyone else came out with their model. Open source versions, closed source versions, Mistral, Facebook, this whole leaderboard of LLMs that they're being benchmarks, and as Jayman mentioned, our customers also used fine-tuned versions of smaller LLMs because it's more efficient, or they use just different versions of LLMs at the same time. So for some more important requests, it could be ChatGPT. For some small classification, it's the smallest model ever. And the AI is changing every day. So in December, I did another presentation in Tokyo, but now all those slides became obsolete. The speed of publishing is really spiking, so which means there's going to be more breakthrough, and it even reshapes how product works. For example, Meta, like talk to your documents, like assistant shape became really popular. And as Jayman mentioned already, so LLM is just a trained neural network. And it's very expensive to train. And for example, ChatGPT was trained on some Reddit data, some YouTube data, Wikipedia, etc. And then once it's done, sometimes ChatGPT doesn't know the answer and can't answer some difficult questions. So sometimes it says, I last updated half a year ago, so I don't know, or I don't have access to your proprietary data, or I hallucinate. But how do you teach LLM to know your data. Let's do a little vector recap. Who here doesn't know what vector is? Cool. Let's just skip this, right? So everything can be a vector, and then it's a multi-dimensional space where each dimension is a feature, and then there could be many dimensions, right? But what I know for sure, if you stack all the vectors together, you'll get matrix. It's basically a new data structure that supports similarity, and you can. Similarity is like how close the vectors are together, and for example, in vector database, as previously mentioned as well, they live in a multi-dimensional space together, and you can retrieve the closest neighbors. So a semantic search is search by meaning, and so this way we can aware of the content. And for example, if you say Turkey trip, Turkey can mean different things, right? Turkey is a country, but also is this animal that people eat for Thanksgiving in America, right? So if I say Turkey trip, semantically, it has a meaning of a country, right? So it knows it's not Thanksgiving gravy oven, because it's very unlikely that you ride Turkey to Starbucks. And as mentioned earlier, we embed vectors, chunk out, and a lot of customers have a lot of unstructured data. Big companies have customer support, financial, all sort of different data. So they chunk in. There's a lot of ways to chunk the data and make it available in embedded to a vector database. And for example, Pinecone supports both dense and sparse vector. So this way, hybrid search is possible. And then you can retrieve your data by querying for top K and finding all the neighbors. And this way, we augment the query, and this is RAG. I should have compared to Taylor Swift. I didn't in the slide. And as mentioned earlier, it's not, it's very efficient, but there is a lot of techniques to improve the efficiency, because sometimes users are really bad at writing the query, and sometimes I type fast, and sometimes I just don't know what I want. Sometimes the accuracy is not great, or the nearest neighbor can be still pretty far, even though there could be some, they can be pretty far. Or sometimes you just don't have knowledge, or don't have those vectors. And there are also issues with context window, like haystack problem, when content window only remembers the top and the bottom, and sometimes it doesn't do well with the middle. Anyone here knows RAG Fusion? Who doesn't know RAG Fusion? Can you raise your hand? Great. So I think 21 person. Great. That's fantastic. So RAG Fusion, using a prompt to generate similar queries to what you're asking. This way, and then retrieve the documents based on them, and then re-rank them. And re-rank already, J-Man already covered. So for example, if I type, wanna learn make latte art, it's a weird query, it doesn't make much sense. Then using this prompt, you are a helpful assistant that generates multiple search inquiries based on a single query, generate queries like this. It generates 4 better structured queries. And in this case, what RAG Fusion does, it retrieves documents from the original query as well as from newly generated queries, and then re-rank them, and then combine the most, assess them and combine the most important, something that fits the best. So now I want to go through self-reflective RAG. And usually, I think J-Man mentioned earlier, all the RAG becoming more agentic. It's really great, but it's a little bit more expensive to run. And one of them is self-reflective RAG. Anyone knows what it is? Can you raise your hands if you know? No? Okay, can you not raise your hands if you know? Wow, everyone knows. That's great. I think AI in Korea is fantastic. didn't expect that. So it's actually a very interesting technique. Self-reflective RAG, it's this research, and it uses, it fine-tunes a model to generate tokens. So it takes the input query, and it generates token if retrieval is necessary. And sometimes, if you ask a simple question that it already fine-tuned good enough so it knows the answer, it just generates the answer without RAG. Or it will take the RAG, and then it will do the RAG pipeline, and then use critique tokens to see if anything else is necessary. It works as a fine-tuned model, and these are the tokens it can generate. Retrieve, yes or no. Is relevant, yes or no. And then fully supported, or partially supported, or no support. And then also how useful it is. And based on it, it does a new retrieval, or like not generate at all. It's called self-RAG. And the last one that I want to bring is corrective RAG. And corrective RAG is a technique that helps you to evaluate the quality of retrieval with a very inexpensive, lightweight evaluator, which is also, I think they use T5 model, fine-tuned, a very small Hugging Face model, or like a very small model, in order to not run like the whole real model, and just to reevaluate the accuracy and relevance of the documents retrieved from RAG. And then this is an example. So sometimes if it's inaccurate, it says like this document is inaccurate. And then based on accuracy, it puts all the documents in 3 buckets, or classifies, triggers 3 actions. Either it is correct, or ambiguous, which is mixed, or incorrect. And it works like that. So it retrieves the documents, and then they assess the quality of the documents. And if it's accurate, if it's in the first bucket, so it triggers yes action, and then generate answer with refined knowledge. If not, it does more searches. And now, so RAG is only one tool. There's also models can search online, they can use SQL, and so other agentic tools are available. So it does some extra retrievals, or it just combines existing retrievals and generate answer with refined knowledge based on this lightweight evaluator that just classifies it as a confidence. And this bucket is just a threshold on the confidence that you can set when you run it. And overall, we have some pros and cons, of course. But I must say which RAG is better. And there's no like one answer or silver bullet. There's always pros and cons. And right now, you can be creative and, for your case, develop new versions of RAG, or as Jayman said, have it modular. For example, with these cases, we have a really well-written blog post that walks you through the code, how to implement it with Pinecone, and I recommend you checking it out. So also, I wanted to show you that this chart that I really like. It shows coding benchmark and compares 3.5 and GPT-4, and it shows that without anything, ChatGPT-4 overperforms ChatGPT 3.5. That's known. But if you use some agentic framework, then ChatGPT 3.5 can outperform, like a smaller fine-tuned model can outperform a bigger model. And the same with RAG, and the quality of retrieval can get much higher if you use more advanced agentic techniques. But as a result, this. And there's a lot of vector databases this day, and Pinecone remains the leader because it can scale the most. We have customers who run billions of vectors, and it's managed, so it's very easy to scale. And on this note, I'd like to walk you through the product and answer your questions. Sounds good? If you come to pinecone.io, you can just sign up for free. And when you sign up for free, you already get a lot of credits that will be enough to run millions of vectors just in the beginning. And then once you log in, you'll see the screen where you fill in some information for us. And then right away, you can just create your index. You can create your index in AI, or based on SDK, there's Node, Python, and just Shell. So we can just try and do it. So an index is actually the index where you can store all your vectors. It has parameters, dimensions, like it could be 8, could be 2, or could be 1,000. And then I have to paste my key. So, but in Python, it's already right here. I'm going to deactivate this later. And right away, right after that, once you create the index, there's a quick link, so you can do a quick start and absort right away. So you can see that here we absort one vector, another vector, and then we query right away. So it's very easy to use, and it comes with free credit. And also, it has a lot of enterprise features, like SSO, RBAC, roles. It can run on private cloud. So, and we are constantly building more features and upgrading it. And on this note, thank you so much. And now, if you have any questions, I'll be happy to answer your questions.
Thank you for your explanation. And then, can I install Pinecone on my local machine?
So you cannot run on your local machine. You can run the SDK on the local machine. But right now, we only run in the cloud. And the reason is that if you have a little bit of vectors, it's easy to run on the machine. But once you have a lot of vectors, it's really hard to scale across the clouds, time zones. And it's actually one of the big things that Pinecone does, and a very large investment that we are doing into the well-run infrastructure that scales really well. So a part of the problem is those hashing, like algorithms, right? How to search vectors, etc. But the other part that is equally very hard is scaling it in the cloud. And that's why it's really hard to run a lot of vectors on the local machine. Very good question.
Hi, I'm Chloe.
Nice meeting you.
So, I really enjoyed your explanation. Thanks for your information. But I have two questions actually. So you introduced 3 types of RAGs. So can I use? Should I choose one of them, or can I use the multiple of RAGs? That's
a very good question. So you can use multiple RAGs, and they all do a little bit different things, right? For example, RAG fusion makes the results, retrieval results, better because it deconstructs the query to multiple queries, and then it retrieves based on multiple queries, and then it searches results based on each query. So it gives you a better retrieval from RAG. And then corrective RAG is a very inexpensive way to evaluate each of them as well. And the self-RAG, it's a little bit more sophisticated, but it makes it a little bit more dynamic. So you can combine actually all of them. And if you go to, I think Pinecone blog is one of the best blogs for RAG and semantic search. So if you go to advanced RAG techniques, there's actually like code examples, how combine all of them. And as you see, combining the methods. So it goes through all the methods that I mentioned and combines them together and brings the concrete code examples in Python. So if you want to play with it, you can just go to a Pinecone blog and just try it out. And I think there's a lot of resources on Pinecone that I really like. We also invest a lot of time into making good materials and writing blog posts and engaging the community. So I recommend you to check it out. Also, something that I really like myself, we run interviews with our customers. We call it RAG Brag, and our customers tell us how they use Pinecone. And it's very interesting to hear because they use multiple models at the same time, how they like store things, how they like optimize inference, and it's always very interesting to see the actual use cases. Very good question.
So the second question is, I recently talked to Microsoft Azure team about RAG solution, and they introduced me their solution to generate the, like auto-generating the RAG, the vector DB for the RAG. So what's the difference between their solution and your solution?
Sorry, they recommend you to
The RAG solution, but it was essentially about generating the vector DB database for the RAG.
Yeah, so we also actually work with Azure, and we are available on Azure Cloud as well. A lot of customers use us on Azure, and then for RAG, yeah, so that you can generate index. So it's actually also can be a very deep topic because I think we had a new, like we have namespaces, and you can enable multi-tenancy for your customers using Pinecone. So you can not only create like index per like project, you can also have like multiple customers using the same index, but have them namespaced. It's up to you. You can create one index per like RAG segment, or if you use the same embed model, you can somehow. But it's still it's free to create indexes. So Pinecone serverless, you only it only takes money for how much you use it, and it's a new thing. So you can generate like 1,000 indexes and use each index for different things, and it will be the same thing as it'll be like more mental separation.
Thank you.
Thank you very much.
Thanks for your presentations.
Thank you very much for listening.
Yeah. My question is, I guess Pinecone, there are a lot of vector stores out there, and Pinecone is, I guess, one of the top 5 vector store, at least in South Korea. Many people love it. And many people use Chroma files because those are free and open source. But Pinecone is not, but still loved by many people. So my question is, what is your thought about this? Why people still pick the Pinecone over the other, even though they need to pay the service?
Yes, so it's also a very good question. And it's like LLMs. It's very complex. So Pinecone is probably the first vector database. And the word the vector database, it was invented at Pinecone. I think by the VP of Marketing, Greg. I think he came out with this term. And after we came out with this term, everyone else claimed to be the vector database as well. There's a lot of complexity. And what Pinecone is really good at is scaling. So Chroma is, based on what I hear and benchmarks, Chroma, you can run it in your local machine. But if you need to scale it for billions of vectors, it's hard. And Pinecone scales really well. It's easy to start using. You don't have to run your inference or like set up your servers. And you can just start using it right away. It's simple to start with. And also, it's better to scale because we are making sure that it's not expensive to run, and it runs really well, and it runs at a scale. So I think that's why a lot of customers end up coming back to us, even though they try different solutions as well. So we do also run on private clouds. We don't run on we can't run on local machine, but we do run on private clouds. And a lot of big customers people from customers from SAP 500, etc., they do run on a private cloud.
I have one additional question. Many people are curious about the semantic search, the functionality and ability over the others because they want to rank well. So vector store is one of the key feature through the RAG pipeline. Do you think, can you frankly tell us about how your semantic search is dominate over the other or any good points?
So semantic search is just embedding so you embed your own text and you just use the vector database to save the information, to keep it fresh, and then retrieve it. So it's just the vector database, right? And it's up to you how you embed it, which model you use. It is, so there's more and more companies running RAG, and the reason there's so many vector databases because it's now such a requested feature, and everyone wants to do semantic search. Everyone is doing RAG. Like, and now, like, I go to any meetup or like in San Francisco anywhere, and all they say RAG, RAG, RAG. I'm scared that I go to a coffee shop and they'll be like, "Oh, do you want to try RAG latte?" And that's a general tendency, and it's if you want to run RAG at a scale and index a lot of information, it's very easy to do with Pinecone. But semantic search itself is how you implement it. You can use all the different complex techniques with the multiple agents, or use just very simple semantic search based on your case, whichever is better. We are a vector store, but we want to make AI knowledgeable.
Oh, okay. Thank you.
Thank you for your question. So if you don't have any questions, I actually have a question to you. So I have some a present, and I'd like to ask you a question, and maybe if you answer it, I'll give the present to you. Sounds good? Why do you think Pinecone is called Pinecone? Anyone wants to guess? What about them? Great, you got it. Yeah? Yes, here you go. A special sticker from New York. Yes, post it on your laptop, tag Pinecone. No more questions? Okay, one more question. I have another present. If you ask one more question, I'll give the present to you. This person asking question.
Thank you. I wonder, the Pinecone's direct technology can support some kind of video data or audio data, not only for text-based data.
Multimodal.
Yeah. So if we use the Pinecone's technology, we can make some.
Good question. Yeah. Thank you for your question. So yes. You can use any kind of vectors at Pinecone, and it can be video, audio, and in the future, models will become maybe multimodal, and you absolutely can index multimodal vectors, because at the end of the day, anything is a vector. They are just matrix. Very good question. And yes, on this note, thank you very much for asking. No more questions. Feel free to talk to me after this. And thank you very much. Let's also thank you to Vessel AI for having me. And thank you very much.